Now this is interesting because we've thought about this graph a little bit already. Sine inverse of sine x. We drew some conclusions about this algebraically, right? We said that this was equal to... Do you remember? We wrote it down. We said it was equal to whatever angle you provided. X. On a certain condition. Namely... We restricted it, didn't we? How did we restrict it? We restricted it from negative pi on 2 to pi on 2. Okay, now a couple of things. I know there are no negative values on there. Okay, so I'm just considering it from the origin. But as you can see, it looks like it checks out. There you go. That sure looks like y equals x. It is y equals x. In this restricted domain, okay? There's two dots very close together because you've got 1.5 and 1.57, which is pi on 2, which is our endpoint. Great, okay? Now what happens later on? Well, you can see what happens, right? Now, it's a bit difficult because sort of, you know, my scale, your inaccuracies of plotting, and people who were greedy and took other people's points and so on, okay? But, what kind of behavior is this thing exhibiting? How would you describe it in words? How is this graph behaving? It's linear, isn't it? It's supposed to be linear. I know down there it looks like it's not being linear, but I put that down to inaccuracies in the graph, okay? Here it's a little more obvious. Whoever was, I won't make you put your hands up and embarrass yourself, but whoever was going from pi on 2 to pi did a pretty good job. Whoever went from pi to, yeah, you know who you are. Now, how far does it go? How far does it go?
Same.
Now let's think about this. I said before I didn't include in negative values, right? So from negative pi on 2 to pi on 2, I'm just on y equals x. Now where's negative pi on 2? It's somewhere like here, isn't it? Around here. Thereabouts. Whoops, sorry, missed. Now have a look at this continuous portion that I have from negative pi on 2 to pi on 2. Okay? Horizontally speaking, how long is it? Horizontally. It's pi radians, right? From here to here. So therefore, it's a reasonable expectation to think that from pi on 2 up to here would also be pi radians. So this bottom point here, right? What would that be? I guess that would be 3 pi on 2. 3 pi on 2, which doesn't look very 3 pi on 2-y, but you know, you're getting the idea, okay? And then of course, it comes back up for another pi radians, okay? Line of best fit, oh well, okay? And then we come down, I think the very last point that someone put on was 3 pi. I think that's 3 pi, isn't it? 9 point, whatever, 9.42, something thereabouts. There you go. Great. Now this is interesting, to say the least. It looks kind of like sine, doesn't it? But it looks like sine and someone beat all of the curvature out of it, right? Okay. Now, I put a little more negative stuff over here. We know already that this is what's going to happen. Now, what might you expect to take place over here? Now, it's a good, you've got good intuition if you're thinking it's going to do the same kind of thing, but we can go a little further than that. We can show algebraically it's going to do the same thing, okay? Here's the way I'm going to approach it. Let's think about symmetry. Okay? Symmetry. For functions, there's two kinds of symmetry, right? What are the two kinds of symmetry? There's even and odd, right? So even symmetry is where a function is the same whether you put in one value or it's negative. That's even symmetry. So, if that's the algebraic definition of even symmetry, what's the algebraic definition of odd symmetry? How's it different? All I do is slap a negative on the front, and now it's odd. Okay, that's an odd function. Okay. Now, what you've got here is a composition of two functions, right? A function of a function. But you know lots of things, especially in terms of symmetry, about both of them, right? What kinds of symmetry does each have? Sine. Odd.
Oh, yeah.
When I say even, I mean odd, you know? Okay. And sine inverse, of course, right? We noticed along the domain that we restricted it, sine inverse had what kind of symmetry? Also odd, right? Also. Cos is the unfortunate one who is even symmetry, but because of the way we restrict it, cos inverse has no odd or even symmetry, not at least in this sense, right? It does have odd symmetry if you take it about a different point, but that's beside the point. Now, therefore, if I know both of these are odd, what happens when you take an odd function of an odd function? Now, you already have some clues when you look at the graph, right? You could probably make a very good educated guess. But can we prove it? Okay. So off on the side, or maybe for me off on the side, but for you underneath here, okay, let's consider some odd functions, okay? Consider two. And let's call them, for the sake of argument, f and g. F and g. Okay? Now, if I define them both to be odd, okay, I want to think about f of g, or g of f, and does it have any qualities that I can take advantage of? Okay? So for instance, both odd and even symmetry, right, have to do with what happens when you stick in a negative, right? F of negative x. Okay? So if I want a function of a function, I'm going to do this. F of g. You see that? So I'm not going to stick x in there, I'm going to stick g of x in there. But I'm not just going to stick g of x, I want g of a negative x, and see what happens using what I know about odd and even functions. Okay? So I'm going to do this. Is that okay? Right, now, we've just defined g as odd. So therefore, what conclusion can I draw from there? This is f of negative gx, right? by g, I mean negative g. It's all the same. Okay. So, because g is odd, I can say this, right? Aha. But now, because f is odd, so it's in this position, right? I can say that's negative f of g. Good. Okay, now bringing that back to my original line, f of g of negative x and negative f of g. What conclusions can I draw therefore about f of g? An odd function of an odd function is an odd function. No. Okay? My brain. All right, now, so therefore, what should you expect a sine inverse of sine? Because it's an odd function of an odd function? Great. So now, I don't need to make any guesswork. I see exactly what's going on over here, so I can draw the same conclusion. Okay? Where am I going to intersect? Pi? At pi? Negative pi? I'm following like you guys now, right? You get the idea. It keeps going, right? I should go further, shouldn't I? Somewhere up here. And it turns around. Okay? Now we're going to come back to this guy shortly, but I want you to then think about, I'm not going to spend time on it. You can see it, it appears in the exercises, and you can look at the videos if you like. But obviously this is not the only way we can combine these and graph them, right? You could just as easily do cos inverse of cos, right? Or you could do tan inverse of tan. You can swap the inverse with the original function. You could do tan of tan inverse and cos of cos inverse and sine of sine inverse. What gets really funky is when you mix and match. What would you expect this to look like? We will address this question, but I wonder how far you can get on your own steam. What would you guess that it might look like? This is what you see this looks like, okay? And how can you argue that it's the case, okay?